The first step to making a motor, when we're making half-inch ID hand-ram black powder motors, is cutting and treating the tubes. This tube's already been coated on the inside with the wax, using the wax coating process for tubes. I'll cut it to length. Typically the length of a black powder motor tube is 10 times the tube ID. 10 times a half is 5 inches. There's lots of ways to cut tubes. For these relatively thin wall tubes, this is the easiest way I have to cut one tube. I put a backup dowel, this is an aluminum rod, inside the tube. I've got a real sharp knife, and I just roll. And that makes a real nice clean cut. So there I've got a cut 5-inch tube. Next, to prepare the tooling, this is half-inch black powder tooling. To prepare the tooling, it has been cleaned after the previous use. I use a little steel wool quite often on the spindle. I like to lubricate the spindle. I have this Liquid Wrench dry lubricant, which I like to use. I spray a little, shake it up, and spray a little of that on there. That helps the motor come off the spindle once the motor's been made. I have a sketch of what a cross section of this motor is going to look like when it's done, for me to refer to and visualize what this motor is going to be like. And I essentially want to now mark do not pass lines and switch rammer lines, and also a top of the nozzle line on all the rammers. I've got a red line. If I put a rammer in until it hits the tip of the spindle and pull it out about 1/8 of an inch, I put a red do not pass line on each of the rammers. So where that goes in all the way, I back it out about 1/8 of an inch, and that's where I put the do not pass line on the 3 rammers. This particular tooling set comes with 3 rammers. So there's do not pass lines marked on all of those rammers. The switch rammer lines correspond with the do not pass lines on the previous rammer. So this is my first rammer. The switch rammer line corresponds to the do not pass line on the next rammer, and the switch rammer line on that rammer corresponds to the do not pass line on the third rammer. And I also put, referring to the sketch, I also put my rammer in as far as where the top of my nozzle wants to be, and I put a green top and nozzle line so that I know when I've rammed my nozzle or pressed it that it has been pressed to the proper height. So I've got switch rammer lines, do not pass lines, and a top of the nozzle line on my 3 rammers. The additional lines that do come in handy that I can also mark on the 3rd solid rammer are at top of the delay. I want my top of the delay to come to right there, so I'm going to mark a top of the delay line on that rammer. And then I know also where I want the top of the clay to come to. I'm going to mark a top of the clay line. So as I'm referring to these lines as I'm ramming the motor, I know that I have a do not pass line on this rammer, I've got a top of the delay increment line, and I've got a top of the clay line marked on that rammer. One additional little tool or feature of this tooling set that comes in handy, we've been talking about it on the website, is a little tube that just barely fits over the end of the spindle. It gets snug on the spindle before it slides down with its top below the top of the spindle. And that tube, which I've made out of gummed paper tape, is also a small enough ID where it will slide up into the first rammer. That paper tube will keep the tip of the spindle centered as I ram the nozzle, which can be tricky to do, so this comes in very handy. So if I put that on the spindle before I ram the clay, and then I ram the clay, making sure that tube's going up into the hollow rammer, I ram my clay. When I pull that rammer out, and once the nozzle has been rammed, that tube either comes off on the tip of the spindle, and I can reach down in there with forceps or tweezers, forceps, hemostat, and pull that tube off the tip of the spindle. Or in this particular case, that tube is snugging up in the end, the hollow end of this rammer, so it'll stay in there permanently, just sort of like Dave Forster suggested doing. And when I use it in future uses, that tube will stay in there, and that perfectly centers the spindle in the tube as I'm ramming the nozzle clay. I won't be using a tube support with this particular motor. I'll just hand ram it without a tube support on it. But if I was pressing a motor at higher pressures, a whistle motor or something like that, or if I wanted to ensure that I couldn't over press this motor, I could use a tube support for this motor. But right now I'm choosing to not do that. It's a little more convenient and quick to not use a tube support, and I'm able to make these black powder motors without one just fine. This is the nozzle clay I'll be using. This is the premium Dr. Elsey's cat litter that a very experienced rocketeer turned me on to, and I just love the stuff. Doesn't need to be treated with anything. Similar to what Lloyd used, the Well Driller's bentonite clay. It's got various color granules in it, light and medium gray granules. Presses up very nice just as is. These are the scoops that are specified in the spec sheet. A flat half teaspoon, 3.5 grams of the clay for the nozzle, and a round 1/4 T for each fuel scoop. One added little step I usually like to incorporate is I like to show exactly on the outside of the tube where the tip of the spindle is. That helps me when I'm pressing the delay increment and the clay increments to know exactly where that spindle tip is. So the bottom of my Sharpie line there is the tip of my spindle. So that's the mark that I'm working off of when I'm actually measuring finally the amount of delay I have in there and how much clay I have in there. If I'm pressing the motor instead of hand ramming it, I want to mark my P2F gauge, or the gauge on my press if there is one, with the appropriate amount of force for this size motor. For this motor I want 750 pounds of force, which is 5,000 PSI on the comp with a hollow rammer. So I'll mark 750 on this gauge, and that's the amount of force I want to apply when I'm actually pressing the motor, if that's the way I'm going to be making the motor. In terms of the chemicals that will be used in the project, this is my Southern Yellow Pine horse bedding pellet charcoal that's been TLUD cooked. It's been put through the garbage disposer, and then it's been put through a 24 mesh screen. I use what has gone through the 24 mesh screen, so it's minus 24 mesh on down to air float. And what stayed on the 24 mesh screen I will regrind later on or ball mill into air float for some other use. So that's my 24 mesh to air float charcoal that's all ready to be used in this. Sulfur comes pretty much as a fine powder, doesn't need to be pulverized any further. This is potassium nitrate that I have ball milled in the large ball mill for about 30 minutes. And what I will do is put that through my 100 mesh screen and use what goes through the 100 mesh screen. So the potassium nitrate used in the motors is minus 100 mesh. After ball milling, almost all of the potassium nitrate will go through the 100 mesh screen. It's pretty fine powder. There's just a little bit that doesn't go through. If I didn't want to ball mill it, if I wanted something pretty quickly, there's just a little bit of stuff that won't go through the 100 mesh screen. If I didn't want to ball mill, if I wanted to get some prepared real quickly, or if I didn't have a ball mill to use, the rocket blender can be used to pulverize the potassium nitrate in the same way, and then I'll screen it in the same way. I've filled a cup about 1/3 full with potassium nitrate, and I'll run it on the rocket blender for about a couple minutes, and use once again what passes the 100 mesh screen. It's now run for 2 minutes. I don't like to run the Rocket Blender longer than when it just starts getting warm, which is usually 2 to 3 minutes. So we'll see how pulverized that is. The Rocket Blender is no longer made and sold unless you can find some in stock at a Walmart or something. So there are other single-serving blenders out there that are available. The Magic Bullet, the Ninja Blender. There's a new one called the NutriBullet that run anywhere from $30 to $100 that can be used. Any of these single-serving blade type blenders work nicely for doing this kind of pulverizing. I'll wash this cup and the blade part out before it's used on a different chemical. Once again, most of this will pass the 100 mesh, and what doesn't I'll put back in with the more coarse crystalline potassium nitrate to be ball milled or pulverized later on. You can see the Rocket Blender doesn't do quite as good a job in 2 minutes as the ball mill does in a half an hour. But now what's on the paper is minus 100 mesh potassium nitrate ready to be used in my rocket propellant composition. What's left on my screen is easily dumped onto the paper and then dumped back into the container of the crystalline potassium nitrate. So I have my 3 chemicals, potassium nitrate, sulfur, and charcoal already. I want to mix the propellant now. A half-inch motor like I'm going to make in this project only uses 13 grams of the propellant. I like to mix propellant in 100-gram batches. It's convenient and easy to figure the amounts that way. I can get 7 of these motors out of a 100-gram batch, or I can save the excess to use in a different, perhaps larger motor later on. But I'm going to mix a 100-gram batch of propellant, which would make 7 of these if I want to knock out a bunch of half-inch motors. And there's not a big difference between the thrust, the impulse from the 75-15-10 ratio to the 70-20-10 ratio. I think I will make a 70-20-10 ratio in this for this motor, these motors. So I want 70 grams of potassium nitrate. I'm going to screen the potassium nitrate and sulfur together into a tub. If I'm making a larger batch, I'll use my large 40 mesh screen. This is a small 40 mesh colander I found at Target or Walmart or someplace. So I'm going to screen the potassium nitrate and sulfur together. 70, 20, 10. There's 70 grams of potassium nitrate. I want 10 grams of the sulfur. And there is exactly 10 grams of sulfur. And then while the scale is still kicked on, I will weigh out 20 grams of the charcoal, minus 24 to air float. Normally all this would be done outside because it is a little bit dusty. Since I'm videoing it, I'll do it indoors here, but this would normally be done outdoors. There's 20 grams of the charcoal. I'll just screen the potassium nitrate and sulfur together right on top of the charcoal. I found I only need to screen this once together, and then if I shake it and dampen it slightly, it does the job. One check I like to do is verify by weighing the mixed composition that I do have within a gram or two of 100 grams. And I've got 101 there, so I know that I didn't forget anything and I weighed each individual ingredient accurately. Now 100 grams per TR's Tom Rebenklau's recommendation, putting 1/2 of 1% of water just to slightly dampen this composition and make pressing it a little less dirty and allow it to consolidate a little better. Each spritz from one of my little atomizer bottles puts out 0.2 grams. I'm looking for 0.5 grams, which is 1/2 of 1% of this composition. So I'm going to put in 3 spritzes from this. Put in the first one, shake it around a little bit, put in the second one, and the third one will put in a total of 0.6 grams, which is 0.6 of a percent moisture in there. It's really not enough to get it significantly noticeably damp. I've found that if I just shake the heck out of this, that it thoroughly distributes the moisture in the composition. I don't have to put it through another screen or anything. This really incorporates the moisture into the comp. And still is a little dusty, but it forms slight clumps in there, which indicates there's a little bit of moisture in it. Now I'm ready to make a motor.